you remember from last week, we did sine, cosine, tangent. One small problem, or one kind of, how can I put this, restriction. Those rules we did last week is only for a right angle triangle. When you have a triangle like this. Yeah? So for example, remember what we said sine theta was? Yeah, and cos theta is adjacent over hypotenuse, and tan theta opposite over adjacent. But the annoying thing is, these only work if you have a right angle. So what we're going to do today is two rules which work for any triangle, which is very nice. So let's do the first one, the sine rule. If you can write this down, we'll do the little proof. What the heck? Come on, let's go. Oh, come on. Oh, here we go. Sine rule. Okay, so first we'll just draw a triangle here. And we'll call this side A, this angle A, this side A, B, B, C, C. So this triangle, it's not special, any old triangle. Let's do the proof. So what we do first, we draw a dotted line here at 90 degrees and call that H. And we can say that sine A, that will equal H over B. And sine B, that will equal H over A. Well,
I lost my key on the way. Yeah.
you lost your key on the way.
Yeah.
What are you talking about? What key?
T. The T.
And so what did you do?
I go back.
Oh, Ming. Maybe one day you will be early. Right. So here we have H equals B sine A. And here we have H equals A sine B. Doesn't it? Yeah. So we get B sine A equals A sine B. And so we get our result. We can say A over sine A equals B over sine B. And we can repeat and get C over sine C. And this is the sine rule. I'd like you to write that down. It's a short little proof. It's nice to have. It's taken Son a long time to buy his Coke. What? He's doing what? He's enjoying his Coke. Okay. You got that? No, here. Okay, you got that? Yeah?
Yes.
Okay. Let's have a look at the next rule, cosine rule. Let's keep it the same. A, B, B, C, C. Very similar proof. Dot, 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 dot. h. This time though, what I'll do, I'll call this side here x. So how big is this side? Well, this side here will be c minus x. And this here is h. And now what I'll do is I'll use Pythagoras. X squared plus h squared, what will that equal? X squared plus h squared equals b squared. And then here, I have c minus x squared plus h squared equals a squared. Now what I'll do is I'll minus. Bella, why are you so late? Now come on, tell me, what's wrong? Why are you so late? Why are you so late?
I overslept.
Oh, Bella. Right. This is x squared minus c minus x squared. They cancel, equals b squared minus a squared. So you get x squared minus c squared plus 2cx minus x squared equals b squared minus a squared. The x squareds cancel. And you can rewrite this as a squared equals b squared plus c squared minus 2xc. So let's just figure out what the x is. If I go back to this triangle, I can say cos A equals x over b. So therefore, x equals b cos A. If I sub that in here, there you are. Did you get your Coke?
No.
No, why not? I thought you were getting your Coke. What
Huh?
the heck did you get? What's that?
Breakfast.
Oh, son, I thought you were just buying a Coke, not buying a breakfast.
I didn't hear that.
You okay? Okay.
Sorry.
Ah, all right, fine. I'm distracted now. Okay. Well, do we have everyone now? We have everyone plus a breakfast. Okay. A squared equals b squared plus c squared minus 2bc cos A. Yep. That's it. That's the cosine rule. Got that? Yeah, it's okay. Yeah? Can I scroll down? No, I see people writing. No. It's really, son, this is what you really need, this result, okay?
Yeah.
Yeah. Have you seen this before?
I learned yesterday.
Yesterday?
This my friend.
Oh, good. Good. Okay, can I scroll down?
Yeah.
Yeah?
Yeah.
Right, let's have a look at some examples. So suppose, for example, here's the ground. Here's the building here. and we want to know the height of the building. You stand here, you look to the top of the building. Whoa, that's not the top. You stand here, you look to the top of the building. Angle here, let's say 20 degrees. Okay? And then what you do, you walk, let's say 3 meters closer to the building. Maybe 20 is a bit too small. I'll make it 30. And then you'll look up again. And this time you look up with an angle of 40. And the question is, how tall is the building? So what we need to do in green is write down all the information we know. Do I know this angle? Yeah, what is it? 90. And I know this angle, so can I know this angle? 50, isn't it? Yeah. Okay, I know this angle. Oh, sorry, I know this angle 40. So can I know this angle? Yeah, 140. Oops, sorry. 140. I know this angle and this angle. Can I know this angle? 10. Great. Now, let me look at the triangle on the left. Let me call this side here X. And let me use the sine rule. So this is how the sine rule works. You say X over the sine of the angle which is opposite X. Which angle is opposite X? 30. Equals 3 over sine of the angle opposite 3, which is 10. Can this give me X?
Yes.
Of course it can. So tell me the X here. Say again?
8.64.
Now, if I know X, how can I get H? No, I don't know this.
Yeah.
Well, I could just say sine 40. What would sine 40 equal? H over X, which we know. So that means X, oh sorry, not X, H equals X sine 40, which equals 8.64 sine 40. 5.55 meters. And that's the answer. Okay, write that down. That's our first example of the sine rule. Not too bad, I hope, huh? That sounded a bit like Siri or Google or
Yeah. Siri.
Siri, yeah, okay.
Hi Siri.
Okay, have you got that? Yep. I can do a cosine example now. Yep. Okay, so okay. So let's say we have the beach here, maybe we have a little ship here, and then we have somebody standing here, and they're looking at the ship, and maybe somebody standing here, they're looking at the ship, or I don't know, whatever. Let's suppose this distance is 10 meters, this distance is 8 meters, and this angle here, I don't know, let's say it's 80 degrees. And we would like to know this distance here. Yeah. For example, something like this. I don't know. Now, this is the cosine rule. The cosine rule, I always think about it as being a little bit like Pythagoras. Because you could say x squared equals 10 squared plus 8 squared, right? Now, if I stopped there, that would be Pythagoras. But why is it not Pythagoras? It's not 90, it's actually 80. So you can kind of understand that cosine is a little bit like Pythagoras. Yeah? We need an extra piece. The extra piece is minus 2 times 8 times 10 times cos 80. Yeah. Well, actually, this is pretty easy. So you just take out your calculator and then just type in the square root of that. And you're done. Say again? Okay. Seems reasonable. Yeah? Okay, write that one down.
So like after that step, you can go straight to the answer and get out full marks.
Yeah, because it's a short one. Okie dokie. Scroll down. Yeah?
Sure.
Now, let me give you one to try. I want you to calculate this angle. What's that? This angle. What's that? And this side. And then finally the area. There you go. 4 things to calculate. You should be able to do it in like 2 minutes. Let's see how quick you can do it.
Okay.
Ming, I like your scarf. It's nice.
Yeah.
Yeah. It matches your calculator. Your scarf. It matches your calculator. They're the same. Yeah. Say again?
Sine 30 is per
Oh, yeah. If you turn the phone sideways, you might get the signs mode.
Oh, yeah.
Yeah. How are we doing? Nearly done?
Yep.
Nearly done? Finish me? You got it? Yeah.
Just for the area.
Yeah. And the missing sides and angles too.
You're right.
Hmm? You got them all? Alright, shall we look at them now? Yeah. So, me, you, and you are the only guys wearing a bit of colour today. Everyone else is wearing boring black or white. We're the only ones with a bit of colour on. That just makes us the stylish tree in the class.
It is what it is.
Alright.
Yeah.
We'll have a look at it now? Yes?
Yeah.
Now, what did you go for first? The side or the angle?
Sorry.
Or the area even too. You forget the area first because you have the 7 and the 8 and the 30. So we might as well do that then. The area,
Is the 1 over 2?
14.
yeah, let me see. It's 28 sine 30.
Yeah.
14.
What's the
14. Okay. Right, I'm going to get this side next, x. So I have x squared is 49 plus 64 minus 14 times 8 times cos 30. So then x is the square root of this number.
4.
Nice. That's actually good because I just made these numbers up. So it's working out quite nicely now. Right. Let's get this angle up here. We'll call it alpha. So I can say sine alpha over 8 equals sine 30 over 4. Is that a half? Is sine 30 a half? It is. Isn't it? No, something. Oh, so sine. So is this 1?
Yeah, 1.
Ah, so I get sine alpha equals 1. That's why it's working out nicely because my alpha is actually 90 degrees.
Yeah.
If that's 90 and that's 30, then we can easily work out the remaining angle here has to be 60. Isn't it? Yeah? Ah, must be a rounding issue.
what if you
No,
use
no, no,
that?
it's not that. If you use the other.
If you use 7 sine 30 over 4 is equals to
7 sine 30.
yeah
No,
7.
sine
Sorry,
angle.
Sorry, sine
I,
30
one, wait,
over
one at
4.
a time, one at a time. What did you say? Use what?
Sine 30 over 4 is equals to sine x over 7.
And what do you get for the angle?
61.
Really?
Yeah.
Yeah.
61.
Then you do angles in a triangle.
Hang on, that doesn't make sense. You're saying sine
30
30 over
4.
4
4, yeah.
equals
Sine. The 60 and the 6.
sine
We
of
don't
sine
know-
theta,
Yeah, we don't know it.
sine beta over
7.
7. So that means then that sine beta equals 7 over 4 sine 30, right? So Bello, type this in on the calculator. beta equals sine inverse 7 sine 30 over 4. Actually, sine 30 is a half, isn't it?
Yeah.
So this is beta equals sine inverse 7 over 8.
It still gives you 61.
Because it's
61.04.
not 4. It's
61.04.
similar by 4.0.
Oh! It's not actually 4.
Yes,
Yeah.
not actually.
Ah, I see. I understand now. It's what is it? 4 point...
0.0002 or maybe like that.
Something like this. I understand. So it wasn't nice numbers. It was just nearly nice numbers. Yeah, okay. Fine. Okay, Bella, that's grand. Thank you. So it seems you got
61.
slightly different result depending on which you calculate first. In the exam, they usually tell you the order, so they might say first get this, then get this, you know, so that's okay then. Okay. Oh, so that must, so then that means this alpha is not,
Yeah, it's
90.
85. It's sorry, 89.5.
okay, so this is nearly a right angle triangle. We can call this, what would we call it? We can call it a semi-right angle triangle, maybe. Alright, are we okay with these? Yeah. Now, some of these questions are very hard. Some of them are very easy. I'm going to tell you which questions to do, but I'm going to tell you what order to do them in, okay? So first, an easy one to start with is question 1. Then I want you to do 4. Now please write down the order, okay? So you have to do 1, 4, 5, 2, 3. Oh. Do I want to give you more or not? Yeah, optional questions. 1, 4, 5, 2, 3. Now, just so you know, number 7, I've seen a question like number 7 in the exam before. It's not so common, so you probably should do 7 as well. And then the rest of the questions are optional. Okay, you can do them if you want, because they're a little bit tricky. So for the exam, you should be able to do, what did I say? 1, 4, 5, 2, 3, 7. You got that? Yeah? Okay. I do encourage you to do all of them, but I know you're very busy, aren't you? Yeah, okay. Right, can you try them for a few minutes and then we'll start the next maths lesson.
Those in the
Next lesson is trig equations.